Key point 1. The human brain is complex and ever-evolving. The brain is a combination of functioning cells grouped into different categories. These cells are responsible for reading, writing, inventing, designing, and everything you can think of. Each cell group belongs to separate compartments in the brain and performs different tasks. For instance, the part of your brain responsible for processing emotions is not the same part that coordinates your muscle movements and body posture. This complexity is why neuroscientists have agreed that we can't fully replicate the brain even after studying it extensively for decades. In short, neurological science cannot fully explain how the brain exhibits high-level intelligence. So, it has been next to impossible to invent machines that think and act exactly like humans. Of course, there are thousands, if not millions, of machines based on artificial intelligence today, and many are intuitive, but none can 100% replicate the human brain just yet. Robotic intelligence is only effective when paired with human creativity and problem-solving skills. And did you know one more reason there hasn't been a match for the brain yet? It's the fact that the human brain is ever evolving. Our ancestors weren't as intelligent as we are today, and the future generations will be even brighter than we are. The brain learns from the environment and the different activities we perform daily, which serves as its ingredient for growth and development. In this summary, we'll shed more light on the evolution of the brain and why it matters to us. We will also explore some groundbreaking neuroscience discoveries and the negative implications of machine intelligence. Let's jump right in. Key point 2. Understanding how the brain works. Constant evolution is a vital characteristic of the human brain, and it's fantastic because with every evolutionary stage, a new part emerges in our minds. An example is the neocortex, which now constitutes about 70% of the brain. Evolutionarily, this brain part emerged millions of years ago, but it's still relatively new compared to the old brain, which is only responsible for survival functions and emotions. The neocortex is the seat of intelligence in the brain. However, we're born with an empty one that knows absolutely nothing. Our genes determine the size of the neocortex, how many parts it will have, and how the neurons will connect those parts to different areas of our bodies. For example, related to the nose for smell, ears for hearing, and eyes for seeing. Although the structure for learning is available at birth, actual knowledge takes place as you grow and interact with the world. The neocortex consists of several regions responsible for cognitive activities. It's accountable for human capacities such as sight, reasoning, reading, and understanding languages. In different species of animals, the neocortex looks almost the same. Regularly explore creative activities to engage different parts of the neocortex and promote creative thinking. The neocortex evolved from the old brain that was schooled by natural selection, causing the old brain and the neocortex to be in constant conflict. For instance, sugar was scarce millions of years ago, and primates needed it to survive. Hence, the old brain would always jump at sugar each time it saw it. But books and nutrition experts have schooled your neocortex to know that too much sugar is harmful, so it will always fight the old brain in this regard. That's why you might struggle to stop eating candies and sweet snacks even when you know you shouldn't have them. But sugar is just one example where the old brain struggles to make decisions harmoniously with the neocortex. That's why learning to stick with the best rational options in conflicting situations is essential. Of course, it may be challenging at first, but try it and keep going when you fail. Over time, you'll get used to choosing the best habits. Key point 3. How your brain adapts and learns. You don't always use the information entering your brain immediately. Most of it is stored for future reference. For example, as you're reading or listening to this summary, your brain is actively processing the information. But multiple other things are happening at the same time, too. Your brain is recording your sitting, lying, or standing position and noting the subtle background sounds. It will store this information, but your attention won't be drawn to it unless necessary. Regularly learning new things gives your brain enough raw materials for effective decision-making. The brain is constantly willing to react to different activities while observing and memorizing them. After all, this is how it learns. The process is even faster when you move and explore. For instance, to know how a school or church looks, you must enter and observe the different parts of the building. The neurons that transmit thoughts and ideas throughout the brain allow you to do this and are also responsible for learning. If you're wondering, a neuron is a specialized type of cell responsible for transmitting information throughout the body. The brain is composed of billions of neurons, nerve cells, that communicate with each other through intricate networks. These neurons are connected by synapses, tiny gaps where information is transmitted from one neuron to another using chemical and electrical signals. Imagine a group of friends spread out in different rooms of the same house, all dying to share the day's news. Sometimes they communicate lovingly, and at other times they snap at each other when they need to pass on urgent information that requires an immediate response. Our brain regions are like those separate rooms where various tasks and functions occur. They share information, like friends passing on fascinating tales or strong signals between rooms, all contributing to the brain's collaborative understanding. While this analogy simplifies the intricate process, it offers a glimpse into the collaborative nature of our brain's functions. Did you know? The human eyes make sudden, quick movements more than once every second. They're called saccades, and these short, unconscious movements help us explore our surroundings and focus on objects of interest.
Congratulations, you've hit a daily streak.
Key point 4. How we develop expertise. The brain has specialized neurons called head direction cells. They're crucial in encoding and representing head movement orientation or direction within the surrounding environment. In other words, they act as a compass to help align the brain with the environment. An example is when you close your eyes. Even with your eyes closed, you'll retain a sense of the direction you're facing. This brain activity is just one of the many things demonstrating our advanced cognitive functions compared to animals. More than any other animal, humans can reason, process information, and foretell what will happen in different circumstances. This suggests that knowledge may be stored in reference points or frames in the brain. Imagine you're playing a treasure hunt game. To find hidden treasures, you need a map with coordinates that tell you exactly where the prize is. Similarly, our brain has a unique map called a reference frame. It helps us understand where things are in relation to each other. Reference frames matter because all acquired knowledge is stored in them, and thinking occurs only when this accumulated knowledge is activated. Here are a few additional facts about reference points. They're found everywhere in the neocortex. You don't always need to think a lot to recall information stored in the reference frames. unless in complex or less familiar situations. Train your brain's reference frames by practicing retrieval. Regularly test your ability to recall details. Scientists began learning more about reference frames when machines like the fMRI, functional magnetic resonance imaging, appeared. fMRI is an advanced machine created to view a live brain and see how it absorbs information. This machine shows the brain's framework with its different parts. Further brain research has proven that a person's brain needs to possess suitable reference frames to be an expert in any domain. To amass expertise in any field, you need a reliable reference frame for storing facts, knowledge, and observations. These reference frames are developed and modified in the brain as you study topics in your field and interact with like-minded people. It also helps if you use visualization and analogies when learning new things. Key point 5. The neocortex is immensely efficient. The information in the brain does not meet at a point. It is distributed into cortical columns. These specialized groups of brain cells work together to process data in the brain's cortex, the outermost layer responsible for higher-order cognitive functions. Each column comprises vertically organized neurons that respond to specific features or attributes, such as orientation, color, or movement. These columns process sensory inputs and contribute to our ability to perceive and understand the world. Furthermore, cortical columns are interconnected and communicate with each other, allowing for complex and integrated processing. The organization of these columns enables the brain to extract patterns, make predictions, and generate a coherent perception of our environment. This discovery is how the theory of 1,000 brains came to be. This theory suggests that because the neocortex comprises millions of small columns, the brain does not build a single model of an object, but rather a collection of models from different perspectives. For example, you might have a model of a cup from the top view, the side view, and the bottom view. These models are combined from different cortical columns to give you a complete understanding of the object. You might wonder what happens when several projections from different columns appear in the neocortex. In such cases, the brain conducts column voting to combine information from various sources and produce a single output. The most common projections will overshadow the least common ones until coming to a final answer. Multiple brain activities happen in split seconds when doing everyday stuff like identifying objects or grasping new ideas. Here are some problems encountered in studying the neocortex, the seat of intelligence in the brain, and how the 1,000 brains theory solves each. It shows how the brain can learn and display object recognition. It describes how neurons discover information received in the brain. It debunks the binding problem by revealing that each object in the world has different reference frames and cortical columns. It describes how the neocortex learns and understands more rigid models of objects using reference frames. Key point 6. AI is still no match for the human brain. Artificial intelligence, AI, has achieved a lot of incredible feats since it started to gain ground in 1956. However, several AI inventors confess they have yet to develop intelligence as advanced as the human brain. The brain keeps evolving as humans continue learning and advancing, making replicating natural intelligence even more challenging. A person's brain modifies each time they learn a new thing or acquire a new skill. AI researchers always look to create more brilliant machines and often invent tools that act almost exactly like us humans. With an intelligence close to humans, these machines can learn new tasks and use logical reasoning to solve problems. We are intelligent not because we can do one thing particularly well, but because we can learn to do practically anything. Jeff Hawkins. AI has come a long way, but there are still many things it can't do like humans, at least not at the time of this summary. The main attributes that differentiate AI systems from the human brain include continuous learning and consciousness. Learning continuously. AI systems are still battling with learning today because they lack flexibility. Neurons in the brain are responsible for its ability to learn continuously. When neurons receive information about a new pattern, they form new synapses on dendrites, appendages that receive information from other cells. AI has yet to replicate this. But researchers and scientists are improving AI systems to exhibit more adaptable and lifelong learning capabilities. An avenue of progress and potential is the development of algorithms that allow AI systems to learn continually from new data without forgetting previous knowledge. Transfer learning technology also enables AI models to leverage knowledge gained from one task to improve their performance on related ones. This approach mimics the human ability to apply previously learned skills to new situations. Consciousness. Consciousness is an integral part of the brain that AI lacks. It involves movement and thinking that form moment-to-moment memories or recorded thoughts. This thinking sets the neurons in sequential motion, creating continuous memories of past actions each time a person thinks. To design an intelligent machine that can replicate this, scientists need to include the ability to move. Intelligence involves learning a world model, which cannot be done without conscious movement. Sensory arrays that perceive things like humans, allowing the machine to gather information from its surroundings. Key point 7. Intelligence hazards. At the start of the 21st century, many saw artificial intelligence as unsuccessful and harmful due to stalled progress. However, within a decade, AI transformed into a leading research field. Now, concerns have shifted to AI posing existential threats to humanity. The worries encompass both malicious use by humans and the idea that AI might act independently to endanger them. The potential misuse of AI, such as invasive surveillance or disseminating misleading information, could escalate as AI systems become more advanced. The concerning prospect of highly intelligent and autonomous weaponry also comes into focus. For instance, visualize a scenario where someone deploys drones to distribute weapons rather than humanitarian aid. Government policies must address all of these concerns and many more potential threats. But it's not just AI that has negative sides. The human brain can also cause trouble. The old brain encourages local competitive behaviors, which can sometimes become uncontrollable. The fight for territory and partners are good examples. Luckily, we can curtail the risks from the old brain by teaching young children morals so they know how to act when they grow up. Life is based on a very simple idea. Genes make as many copies of themselves as possible. Jeff Hawkins. Unlike the old brain, the neocortex is even more dangerous because it's more exposed and advanced. The invention of birth control is a prime example of the neocortex's intellectual power that allows humans to have sex with a reduced risk of pregnancy. The old brain lacks intelligence, but the neocortex knows the model of the world and can, therefore, make inventions to favor itself. Some of these inventions support the desires of the old brain while preventing side effects or the risks accompanying it. Anything powerful can be misused if not well handled. Despite how smart the neocortex is, it can still be tricked into believing false information, so always filter what you trust. But it's not all gloom and doom. We can be safe regarding AI if good policies are in place. More humans will become geniuses by combining their brains with advanced computers and influence the world for good. Choose to join that league. Conclusion. A machine or a human is said to be intelligent after it has followed and learned the model of the world. The part of the human brain majorly responsible for this activity is the neocortex. The thousand brains theory helps us understand the activities of the neocortex better. Through it, we realize that the brain has a sequential and specific way of creating intelligence. The primary way the brain does this is through learning. It helps the brain memorize how the world operates and internalize the model of several items to spark recognition when necessary. Though AI has made much progress in recent years, it remains insufficiently intelligent to replicate the human brain's complexity fully. The major hindrance to matching human intelligence by scientists and manufacturers of artificial intelligence is a lack of understanding of what intelligence is and how to harness consciousness in machines. However, by understanding the human brain better, inventors may be able to create devices that will match human intelligence and improve life. Some recent innovations scientists are working on include connecting the human brain with computers, and carrying out surgical operations involving implants in a way that radically improves health. AI is fast-growing. It has negative and positive sides, and it's essential to be aware of that when developing or using AI tools. Try this. Be determined to learn everything you can about your chosen field. It will help you develop suitable reference frames in those areas of interest and become an expert. Set aside time each day for deep thinking, when you can focus on your thoughts and ideas without distractions. Use this time to reflect on your learning, brainstorm new ideas, and solve problems.